Hello everyone. In the previous 3 videos, we have discussed what are heaps, added and deleted elements from a heap and analyzed their time complexity, and we looked at the buildHeap function and how it takes O of n time. If you haven't checked out these videos yet, make sure to watch them before continuing here. Also make sure to subscribe my channel, it helps me a lot. In this video, we'll take a look at the code for heapify up, heapify down, build heap using insertion operation, and the build heap function itself. First, let's see the heapify up function. Here, first we check if the index is 0 or not, because if the index is 0, we are at the root and cannot go up, so we do nothing and return. This is a base case. There is one more base case where we compare the parent and the current element using the less function. In case of a max heap, if a parent is greater than the child, then the less function should return true and we stop and return. In case of a min heap, if the parent is less than equal to child, then the less function should return true and we stop and return from the heapify function. If this is not the case, we swap the two elements and perform the heapify up operation on the parent element. We have already discussed how we get the parent element in this video. Make sure to check it out. Now let's look at the heapify down function. In this function, we first get the index of left and the right child. Again, if you want to understand how we get them, you can check out this video of mine. Then we need to find the appropriate node among the 3 nodes, the current, the left child and the right child. For this, we make use of the less function as we have seen earlier. We first assign the apt node variable to the current index and call the less function with the apt node and the left child first, then the apt node and the right child. In case of a min heap, the apt node should store the index of the smallest element. So less should return true if child's value is smaller than the current node's value. So the apt node at every point stores the smallest child's index or the smallest node's index. And in case of the max heap, the apt node should store the index of the largest node. So less should return true if the value at child is greater than the value at parent. Then, since we had first assigned the apt node to the current index, we first check if the apt node has changed or not. Then, we swap the current index with the apt node and heapify down on the apt node again. Also, before calling the less function, we need to make sure that the left and the right indices exist in the underlying array. So for that, we check if they are less than or equal to the last index or not. Now let's build a heap using the insert operation. If we are given an array of elements which need to be inserted into a heap, we would first append it at the end of the array and then perform the heapify up operation on that element recursively. This will make sure that at any point the max or the min heap property is satisfied by the whole heap. As discussed in the last video, which you can check out here, it takes O of n log n time. And we can do better using the buildHeap function in place, in which we can go bottom up and heapify in the downward direction. This takes O of n time. But why do we start from the length of the heap by 2 minus 1 index? This is because in any heap, you would notice that the last non-leaf node will be located at the length by 2 minus 1 index. So we start from that index and go up till 0, where at each index we heapify down recursively. That is it for today's video. Thanks for watching this. In the next video, we'll discuss how to use the container/heap package in Go. Please make sure to leave a like if you learned something and subscribe to keep learning. Thank you.